So let's
Sir, can
jump.
I turn on my camera in 5 minutes?
Yeah, sure.
Thank you, sir.
Okay. So we start our discussion. Our discussion today would be where we left on the other day with a preliminary idea about specific heat. So we will go and this is something which is important from your higher grade perspective also if you study physics. So specific heat capacity. When we talk about specific heat capacity of a substance. Now, before going to this topic, let's try and understand what we are trying to address in this particular what do you call section. Okay, try and see. Okay, so let's say that I have got a body. Okay, I've got a body. So this is a body, and this body always has some internal energy with it, which we call as enthalpy. There is some internal energy. That is the energy associated with the molecules and the particles of this body. This is internal energy. Now, say suppose you start applying heat externally to this body. We start applying heat to it. Now, heat is a form of energy, right? So if you supply heat to this body, then definitely the body's energy is going to go up, right? Because heat energy is being absorbed by this body. And we talk about temperature. What is temperature? Temperature is a measure of what the heat content of a body. Heat content of a body. So we say here that if a body heat content of a body. So if a body has more heat, the body's temperature should be more. If a body has less heat, the temperature should be less, right? Now, if you look at this body, now this body, initially it had only the internal energy. Now external energy is also getting supplied to it. So the energy is going up. That means we are going to observe something which is known as rise in temperature. Right? The rise in temperature. Now, how does the temperature rise? Okay, how does the temperature rise? In order for the temperature to rise, the body has to absorb heat, right? The rise in temperature depends upon the heat absorbed. Heat absorbed. This is the fundamental understanding. A body has internal energy associated with it. This body is getting supplied by heat energy externally. If we supply heat energy externally, okay, just for since everyone is present here, Friday, Thursday we have at 10:30. Friday also we have at 10:30. So Friday also will have a free evening for you. Okay, 10:30. Same Thursday, Friday, show your face at 10:30. That's all. So the energy content goes up. If the energy content goes up, the temperature of the body rises. Now the temperature of the body's rise in temperature is dependent upon the amount of heat that the body has absorbed. Let us first understand this thing. Now, this body, let us now think that this body is comprising of, say, substance S1, S2, S3, S4. These are the different substances through which a similar body, let's take the shape of, say, a cricket ball or the shape of a football, okay, or a cricket ball, very nice. So the same size and the same shape, right? We are once making this body out of S1, which may we say copper. Next time we are making out of aluminum. Third time we might be making it out of, say, iron and zinc, S1, S2. Now the difference that we will try to see here is that the rise in temperature would not be same for all different type of bodies, right? Say, for example, I started heating the copper ball and I started heating the aluminum ball. You will find that the aluminum ball's temperature is rising much more quicker than the rise in temperature of the copper ball. Are you trying to understand it? Okay, that means the copper ball, so what we say, if you see the temperature rise against time, we won't see a linear pattern from everybody, for everybody. Right now, we are saying these are all metals. We may convert them into, say, liquids, metals, non-metals. So what do we understand from here? Were we not heating the copper body? Yes, we were heating the copper body also. They are all on the same furnace. But why is it so that the copper body is taking time to show the temperature impact, whereas the aluminum body is showing the temperature impact very quickly? One single short answer: the copper body is absorbing more heat. वो खाए जा रहा है. right? The heat is absorbing more heat. So we say that different different substances have different heat absorbing capability. Have you understood what we are trying to say? Different heat absorbing capability. It's just like, as I told you, it's the scenario of interrogation versus the amount of pressure that is put on the person who is being interrogated. Somebody might start answering the questions just with 2 rounds of interrogation. Somebody, if you go on interrogating, pressing higher and higher, you start putting more pressure, still he is not giving you the truth. So it depends upon how much of pressure can one person absorb, yet not show the symptom that he is being pressurized. So aluminium in our case gets pressurized very quickly. Pressurized means, in the language of human being, aluminium cannot absorb that much heat, whereas copper is able to absorb much more. So if you see a copper vessel and an aluminium vessel of same size and same shape, you will see that the copper vessel is taking more time to heat up. It's not that it's a bad conductor of heat, it just absorbs more heat. The aluminium is getting heated very quickly. But say suppose we have cooked 2 pots full of biryanis. If you have cooked the biryani in the morning and you are storing the biryani in copper, then the biryani will remain hot for a long time, because if my absorption is more, my release will also take time, whereas the aluminium is going to release very quickly. That's the basic difference between, say, a Chinese and then a Mughlai cooking. If you see Chinese cooking, then we use those woks which are very thin, high flame cooking. The wok gets heated up very quickly, and 1 round of chow mein made, and after that time again you will see he can touch the wok. Wok thanda bhi ho jata hai. Whereas if you see Mughlai cooking and all, it will be in that big, very thick type of a vessel. So from here, this particular difference in phenomenon, where everybody behaves differently in terms of its absorption of heat, we bring a concept which is known as specific heat. Okay, we bring a concept which is known as specific heat. I'm not talking about specific heat capacity now. Specific heat. What is specific heat? Very specific. It's something very specific. I want dress of that specific color. You're now being very particular. You're not going to refer to any era heat. You're very particular. Specific heat. Amount of heat required to raise the temperature of a defined amount of substance by 1 unit. By 1 unit. That means what I'll do, I'll first freeze the quantity of this body. Freeze the quantity of this body. In other sense, what I'm freezing? I'm freezing the mass. I'm making the mass constant. Pehle to ek mass le lo. Because you can't compare apples with oranges. The amount of heat required to heat up a pin and heating up a karhai are 2 different amounts, right? So first fix the mass. So, okay, sir, let us take one frying pan. Similar frying pan of similar mass. Now make different frying pans of different materials of the same mass. Now you are interested to find what is the amount of heat, what is the amount of heat that is needed to increase its temperature by 1 unit. What is the increase? The increase in temperature of 1 unit of a defined quantity of a substance. Have you understood? So can we make it more better now? Let's make the definition more better. We can make it more better by saying that this heat is also always represented in Q. Okay. How much of Q do I need to raise the temperature of fixed amount, right? 1 kg of a substance. Now this 1 kg of a substance can be 1 kg of copper, 1 kg of silver, 1 kg of water, whatever, by 1 degree centigrade. How much of heat is required to raise the temperature of 1 kg of a substance by 1 degree centigrade or 1 Kelvin? Now why did I write these two? Kelvin and centigrade or Celsius are 2 scales where difference means the same. What is the difference between 23 degree and 22 degree? 1 degree. What is the difference between 23 Kelvin and 22 Kelvin? 1 Kelvin. So both are in difference wise, you need not break your head. So whenever I told you once, there will be some questions on difference. This is the section where we'll get questions on difference. So you need not bother whether the temperature is given in Kelvin or whether the temperature is given in Celsius. Why? Because difference between two temperature in Celsius and difference between two temperature in Kelvin is exactly the same. I hope you are fine with it. Are you understanding what I'm saying? 100 minus 0 is how many degrees? 100 degrees. 100 degrees, 373 Kelvin. 0 degrees, 273 Kelvin. 373 minus 273 is 100 Kelvin. Okay? So then we come to specific heat capacity of a substance, of a particular substance. Can I just rub this portion? Okay. If I say specific heat capacity of a substance means, now I will say what is the amount of heat energy, the amount of heat energy required to raise the temperature of a unit mass mane 1 kg, unit mass of a substance by 1 degree Celsius, or it can be 1 Kelvin. We usually say 1 degree Celsius. Okay, 1 degree Celsius is easy, is defined as the specific heat capacity of the substance. Specific heat capacity मतलब imagine the substance to be like a kangaroo. वो अपना पाउच में जैसे बेबी ले लेता है, कितना हीट ले सकता है without showing any increase in temperature. So the moment it just tries to show 1 degree rise in temperature, at that time the amount of heat that has gone inside the belly of that kangaroo is the specific heat capacity. Okay? So we say how to get this derivation is also very easy. Heat supplied, okay, to a body, that is heat absorbed by a body, is directly proportional to the mass of the body. Right? Heat supplied is directly proportional to the mass of the body. जितना mass ज़्यादा रहेगा उतना heat ज़्यादा absorb करेगा. Obviously, heat absorbed by a body. Just say take a steel pin and take a steel kadhai. The steel kadhai will take more time to get heated up. So heat is directly proportional to mass. The heat is also proportional to the difference in temperature of the body before heating and after heating. Heat means heat absorbed by a body. Your temperature was 36, say body's temperature was 34 degree, body right now is at 50 degree, 16 degrees difference in temperature. That means body must have absorbed some heat. Let's say there is another body who from 34 degree went to 70 degree. Don't you think that difference is much more? 14, 24, 34 degree, 36 degrees is the difference in temperature. So the 36 degree difference in temperature must have absorbed more heat. Obviously. Yes or no? So if you combine these two equations, then with proportionality we can write heat is directly proportional to m delta T. Now don't get confused out here. Your book will write everything as delta theta. Delta theta means is the temperature difference. They are using delta theta because they think children might get confused with delta T as time. We are habituated to delta T, so I'm writing delta T. Delta T also means the temperature difference. Okay. So if I want to equate these two equations, what do I write? Heat should be equal to some constant multiplied by m multiplied by delta T. Right? This heat in physics is always denoted by the letter Q. Okay? इसको Q करके लिखते हैं. So all these also I am replacing slowly. Heat is represented by the letter Q. So इसमें हमने इसको Q लिखा, इसको भी हमने Q लिखा, इसको भी हमने Q लिखा. This is also Q. So now finally in terms of Q I am writing Q is equal to m into delta T, and this particular constant is known as the specific heat of the substance which is denoted by C. C is the specific heat capacity. ये जो specific heat capacity है, this is nothing but C. So if you want to define C from here, what do you write? C is equal to Q divided by M delta T. On this, we'll do a lot of problems. Don't break your head on delta T because it's a difference in temperature, right? So now you see whatever definition you wrote, that's C means amount of heat per unit substance to raise the temperature by 1 degree centigrade. So what should be the unit of C? Heat is always measured in joules per kg degree centigrade, or it can be joules per kg Kelvin. This is specific heat. Specific heat of a substance is said to be the amount of heat required to raise the temperature of unit mass of a substance by 1 degree centigrade. Is the concept understood? Right? Why is this so? Because, sir, every body has a different heat absorbing capacity. Based on the heat absorbing capacity, we say that for the same mass of two bodies, there will be different amount of heat required to raise their temperature by 1 degree centigrade. If this understood? Now, what is the implication of this? To understand the implication of this, we take something which is like, say, water, H2O. Now, water is something which is said to be, water absorbs huge amount of heat. Water absorbs, this is a motherhood statement I'm saying. Water absorbs huge amount of heat. पानी बहुत गर्मी को झेल लेता है, energy ले लेता है. That means, in terms of physics, I'll say that the specific heat capacity, of water must be high. Yes or no? Specific heat capacity. इसमें ये amount ज़्यादा heat पीता है तो इसमें heat पीने की capacity ज़्यादा है. So you will be surprised that the specific heat capacity of water is 4,200. They take it. It should actually 4810. So 4,200 joules per kg degree centigrade. It means that if you have 1 kg of water, this is 1 kg H2O. Right now it is at a temperature, say, it's actually they measure it also. There's a particular measurement. Let's say it's 14. Let's say the temperature is now 14.5 degrees Celsius. In order to make its temperature go up to 15.5 degrees Celsius, you have to supply how much of heat? 4,200 joules. Are you understanding? Water absorbs, means if water is a person in the interrogation cell, water doesn't open its mouth so quickly. You have to go on applying heat, Compare this with paraffin or say wax. That's now Diwali is coming or any other thing. All of you, while lighting candle, you must have got that experience of, little bit of molten wax falling on your lighting fingers. Immediately it is quite painful if you see, just when it falls. Have you had that impact? The molten candle now falling on your finger, it's quite burning. So that means candle's temperature goes up very quickly. Candle does not have the capacity to absorb so much of heat. Paraffin does not absorb that much heat. So we can use this we can have this to our use also. Like, say, for example, patients using hot water bag. What is their necessity? Their necessity is to have hot water compaction. They can't keep water along with them, so they fill the water in a bag and then they go and watch television. Suppose they're watching television for 2 hours. In these 2 hours, you want the water to be hot. And water is very good. Water to piye ja raha hai, yet the temperature should be such that you should be able to bear the compaction. Otherwise, if you burn your skin, then what is the... But the good point is that if we fill hot water bag, obviously with water, it will have a very long sustained release also. It will not get cold so quickly. But if we would have replaced the hot water bag and we would have filled some other fluid in it, say lime juice or something, yes, it will be heated up. It will get cooled also very quickly. ये आपको impact नहीं देगा. Got it? Similarly, like ice. ice has a capacity to bear a lot of amount of heat before it will melt. But like nowadays, if you buy ice creams, as I was saying the other day, if you buy ice creams from Big Basket or say Blinkit, the ice creams come with ice packs. Those ice packs are substances which are water-like. It's not water. It's even advanced grade of water. It's a substance whose specific heat is even higher than water. Means by the time the ice cream reaches your home, that thing should not melt. It will, and what is it getting? It is getting the atmospheric heat into it. Obviously, we are in ambient condition. The person bringing the ice cream is bringing the ice cream under the ambient condition. So heat energy of that ice pack is going on increasing, but it is showing no symptoms of rise in temperature. Had it been any other thing, the rise in temperature would have been much more quicker. Say, for example, if you use, say, any sort of hosiery substance, like say vest or something, and you and it's like very hot, not humid, very hot place. You wet it completely and then you just put it on the chair. In few minutes, you will see the temperature going up, and it has absorbed all the heat. उसका specific heat capacity कम है. Now again, on the same side, we spoke about water. Let's talk about something called a frying pan. A frying pan. What is the purpose of a frying pan? What is the purpose of a frying pan? The purpose of the frying pan is to heat the oil and assist you in cooking. And what do we talk nowadays all about? Fuel efficient. Fuel efficient means when you switch on the gas, if you see an iron frying pan and a non-stick frying pan, the non-stick frying pan will heat up very quickly. If you see the backside of the non-stick frying pan, it looks like a shiny silvery surface. So they are making it with those materials whose specific heat capacity is very, very less, so that थोड़ा हीट करते ही टेम्परेचर बढ़ना शुरू हो जाए. इससे हमारे गैस की बचत होगी. That's why pressure cookers are made up of aluminiums and alloys of aluminium. They heat up very quickly. So be very careful when you're answering what. So if somebody says, sir, I have got a hot glass of, say, Bournvita, you want to keep it on the pressure cooker will heat up quickly. The Bournvita will not. See, understand one thing. In order for a substance to cool down, you have to allow a long temperature gradient. This is your Bournvita. Okay. And you want the Bournvita to come to this level, this temperature level. So you have to allow something whose temperature gradient is very high. Water is like that. Water is going to absorb all the heat of the Bournvita and yet not become hot. Because if water becomes hot, then the temperature difference between water and Bournvita is very, very less. If this temperature difference is less, you can't attain much cooling. Think, our Bournvita is at 50 degrees centigrade. Our water is at 45. And imagine water is not having good specific heat capacity. So what will happen? Bournvita's temperature initially will come down to how much? 48. Water will also attain 48. No more gradient. It has become straight. Now will heat transfer between the two? No. Bournvita ठंडा ही नहीं होगा. ठंडा होने के लिए आपको ये मेंटेन करना होगा. अभी अपना water is very easy. Bournvita was here. Water इधर ही रहता है. आप बेटा देते रहे heat मेरे को. बड़ा सा temperature gradient रखेगा and the Bournvita cools down. Or else sometimes people use hot tea between two vessels. They do it in long process. Why? So that this vessel should not get quickly heated. If this vessel gets heated and both the vessels are at the same heat, they will not be able to reduce the temperature. Another way that your mom and other does is you get some rice or khichdi, they'll spread it over the whole thali so that the heat is absorbed by the thali. But if you are eating in a steel thali, a steel plate will not be able to cool down the food much because steel specific heat is very less. Steel itself will get heated up. But if you pour it in an earthen matka will happily absorb. Jalda jaldi thanda ho jayega aapka. Clear? Have you understood what is specific heat? So when we do problems on specific heat, although the problems at Cambridge level are much more simpler, here ICSE is very good. In ICSE, what do we do? You have one common idea about how a problem is done. Let's say I have water out here. This is only water, and you have brought a hot iron object into it, right? Hot iron object into it. And then they will say, So water was initially at a temperature, say WT1. If you bring the hot iron to it, what will happen to water's temperature? Water's temperature will shoot up to WT2. Agreed? Hot iron had come at WI1, and then hot iron's temperature will what happen? It will get cooled down to WI2. Have you understood this or not? This is the initial temperature, this is the final temperature. Can energy be created? No. Can energy be lost? No. Energy only gets converted from one form to another. Assume that there is no exchange of heat with the surroundings, then such sort of problems are solved like this. Heat lost by iron must be equal to heat gained by water. Do you agree or not? Because the heat cannot disappear somewhere. This is very, very ideal. I am not telling you about there will be this vessel which is holding the water will also absorb some heat, but I'm taking a very simple case. So heat lost by Bornvita should be heat gained by the water. Now, if you take some substance out, what do you want? You want the Bornvita to cool down. So you want the heat to lose, more heat to be lost. Therefore, more heat should be absorbed. So whenever you're cooling something, please select an object which has high specific heat. That's why we use water. You can't use alcohol out here. Alcohol फट से गर्म हो जाएगा. Then Bornvita is also hot. Alcohol is also hot. ले ठंडा ही नहीं होगा. So let's see this formula. So what is the heat lost by iron? The mass of iron multiplied by the specific heat of iron into the temperature difference of iron. Now what is the temperature difference of iron? The higher temperature is WI1. Remember, if we get a problem like this, WI1 minus WI2. Have you understood? Should be the heat gained by water. How much of water we have? Say the mass of water, MW, into the specific heat of water, into the temperature difference of water. What is temperature difference? WT2 will be a higher temperature minus WT1. ये बेसिक याद करने से आप सब प्रॉब्लम कर सकते हैं, आपको कोई रटने की जरूरत नहीं है. In ICSE grade 10, they have very good questions. They will have pressure cooker, water, and inside that we are putting iron. So how is the equation? Heat lost by iron is heat gained by water plus heat gained by the pressure cooker also. So instead of one more, I should have one more. Mass of the pressure cooker into specific heat of whatever material, aluminum, into rise in temperature, because energy in the whole process can neither be created nor be destroyed. This is the maximum complex way I have tried to explain you. If you have understood this complex way, then your book problem will appear very easy to it. Remember, heat absorbed by a body, just keep this formula in your mind. Q equal to mc delta T. That's it. Mass of the body, and in your book the formula will be, mc delta theta. You do whatever you want. Delta theta is the change in temperature. For you, the change in temperature is delta T. When you are solving such problem, don't be a dumbo idiot to take delta T as negative. Because whether you are losing or gaining heat, we are interested in the quantity of heat. Have we understood? देखें numericals थोड़ा सा, ठीक है? And then we will go into latent heat also. We'll solve latent heat problems also with this concept. Latent heat में कुछ नहीं होगा. Latent heat में this delta T will be 0. Because in latent heat, temperature change doesn't happen. So that means this whole, because if you put delta T in latent heat में delta T नहीं होता है ना. The amount of heat required to melt 1 kg of ice at 0 degree to water at 0 degree. That means in latent heat, the heat, this will become 0. Delta T becomes 0. So we do not put this. Instead of C, we put something called L. L can be LF or LV. LV is latent heat of vaporization. LF is latent heat of fusion. Again, chemistry first chapter, same things will be repeated. That's why in those I taught you at detail what is cooling curve, how does boiling happen. Remember or not? What is melting? Melting is a constant temperature process at which the temperature still remains 0 till 100% of solid has converted to 100% liquid. During this process, what happens to heat? The heat is going, but it is not adding to build up the kinetic energy of the substances. Rather, it is going and breaking the bonds. If it builds up, if it adds to the kinetic energy, then it will show up in the temperature. ठीक है, चलिए एक प्रॉब्लम करके देखते हैं on these. Let's see whether we can do or not. Very easy questions. Okay. Now the question says, if 20,000 joules is supplied. Okay, so let's take our problem. Our problem is heat supplied. Heat supplied is equal to 20,000 joules. If 20,000 joules is supplied to a mass of 5 kg, given that our mass, which is m, heat supplied is what, beta? Q. M is equal to 5 kg. Everything should be in SI units. 5 kg, and its temperature rises. Okay, rise in temperature is from 15 degrees Celsius to how much? 25 degrees Celsius. 25 degrees Celsius. So we would say our delta T is equal to how much, beta? 25 degrees Celsius minus 15 degrees Celsius, which is 10 degrees Celsius. It says, okay, calculate the specific heat. We have to calculate specific heat, and specific heat is denoted as C, which we don't know. So use our expression. See, now since I have written everything out here, there is no issue. I can just write Q is equal to MC delta T, which tells me that C is equal to Q over M delta T. Q's value is given as 20,000 divided by 5 kg multiplied by 10, right? So this 0 gone, 5 4s are 20, 0 0. So it's 4,000 joules per kg degree centigrade is the specific heat of the substance. See whether you have been able to do on your own or not. 4,000. Dhruv, तेरा वो pen मिल गया, इधर ही था. I've kept it. Okay. (400 joules per kg degree centigrade). Okay, if this problem instead of Celsius would have been reported in Kelvin, still nothing is different for us because it will be delta T at delta T. But in that case, the answer should be reported as joules per kg Kelvin, not degree Kelvin, Kelvin. Okay, can we do one more problem? Let's take one more problem. Chalo. Let's take one more problem, and it says 25,000 joules of energy. So this time I'm writing as Q. You should write Q means heat supplied. 25,000 joules. Okay, 25,000 joules of energy is supplied to a mass of 2 kg. M stands for mass, which is 2 kg, and its temperature rises from 10 to 35 degrees Celsius. So delta T is equal to 35 degrees Celsius minus 10 degrees Celsius, which is 25 degrees Celsius. Calculate the specific heat. आप खुद करो तो Q क्या लिखोगे? MC delta T, और C is equal to Q upon M delta T. Q की वैल्यू कितनी है? 25,000. What is the value of M? 2. What is the value of 25? So 25 straight away takes 25 as 1,000, and 2 takes off 1,000 as 500. So it's 500 joules per kg degree Celsius. How many of you used calculator? Hey Kirtan, you've used calculator, na? Ah, I can see your face and I can guess. Did you understand this? All right, good. Let's take one more problem. Okay, here we can get a lot of ATP questions. इसके बाद थोड़ा सा ATP question देखेंगे इसके ऊपर, ठीक है? We'll get some ATP questions also. One more. Bacha, can we do one more question? Ashmita madam, all okay?
Yes, sir.
Yes. What's special for Diwali, Dhanteras? Nothing. I don't make that faces. अरे पूजा तो मैं भी जानता हूँ. पेट पूजा क्या है वो बोलो. पूजा अपने I making a sweet and making a sin. Everything is in English, you know. हम मिठाइयाँ नहीं खाते हैं कुछ भी. हाँ मिठाई खाओ यार, क्या तुम लोग इस उम्र में ये वाला रोल खाओ ना, खाओ पेट भर भर के खाओ. Okay, next. The next question is how much energy has to be supplied. So our next question is how much energy has to be supplied. Okay, हमें energy कितना supply करना है वो नहीं पता. To a mass of 3 kg. So the mass of the substance is equal to 3 kg. Okay. Kilo problem. Of material of specific heat capacity 500. हमें specific heat capacity दे दिया है जो कि है 500. Okay. Sometimes beta be very particular. Sometimes they may show it in kilojoules also. Joules per kg degree centigrade. Sometimes it may be in kilojoules. Do not be a scapegoat. To raise the temperature by 10 degree means delta T is 10 degrees Celsius. So we need to find out what is Q. So Q is equal to mc delta T, or you write mc delta theta as your book. So m into 500 into what? Delta T, which is 10. So 500 into 10 is 5,000. So this will be 15,000 joules. But do we exactly get 15,000 joules as our thing? Let's check. 3 means 3 kg. Okay, sorry. So we'll just check the units. एक बार unit को check कर लेते हैं. kg is being multiplied with joules per kg degree centigrade being multiplied by degree centigrade. It means that kg cancels kg, degree centigrade, an answer should come only in joules, which our answer has come. समझ में आया? बहुत बढ़िया. Then, how is the calculator behaving? All okay? अच्छा, good. चल go ahead. चलो थोड़ा और देखते हैं. अब देखते हैं थोड़ा सा ATP टाइप प्रॉब्लम देखते हैं, ठीक है, जिसमें हम लोग क्या करेंगे, we'll just see, let's see a ATP type of setup. So we'll try to verify whether this happens or not. So how do we verify? Say we'll take in a container in such a manner that it is thermostatly sealed, and you have got water out here. You have got water, and the content of water will be known to you. So M is known to you. C for water is known to you. The C for water is around 4,200 joules per kg degree Celsius. Okay, and we will have thermometers which will actually check the temperature right before we start to heat, and we'll also check the temperature after we have heat. So basically from this setup, the delta T is also known to us. Have you understood? And how are we heating this? This time we are heating it through a electric heater. यही पे catch है problem का. You're heating it through a electric heater, right? And the electric heater, so how do you verify? You should find out that the heat supplied should be equal to, so from this side, how much heat absorbed? Heat absorbed, we can easily find out, which is equal to mc delta T. We know M, we know C, we know delta T, right? In order to verify this, we should also find that this should be equal to the Q supplied. And who is supplying the heat? The heat is coming from, basically the heat is coming, not Q, I would say electrical energy of a different form. The same energy is converting into heat out here. अब ये वाला आपको कैसे देगा? This is being heated by an electric heater, so they will give you the power rating of the heater. Power rating दे देगा, power rating, and they will also give you the time of heating, or not time, rather the better English would be duration. The duration of heating, ये दो आपको दे देगा. तो यहाँ थोड़ा सा दिमाग लगाना है. पावर का, power we have to understand. Power is given as the rate of doing work, that is energy upon time. So energy should always be equal to power multiplied by time. So suppose they give you a heater. The heater is 20 kilowatt, 20 kilowatt heater, and it has been run for 10 minutes. Now this is sufficient to confuse you. You will take kilowatts, you should take it into watt, because you should understand 1 watt is 1 joule over 1 second. You have to bring everything to SI unit. 1 watt is 1 joule over second. So 20 kilowatt means I will write 20 into 10 to the power 3 watt. Have you understood? into time. Time is 10 minutes, which is 10 into 60 seconds. So what am I multiplying here, bacha log? I am multiplying, if you see this, I am multiplying watts with seconds. What is watt? What is joule over second multiplied by second? Second cut. Basically, I am getting my answers in joule. इसको समझे हो तो नहीं समझे हो तो पूछो. I can tell you. There may be a question. Okay. Now, this is a question where we are trying to heat up water, right? Now, how much what heat did the water absorb? The heat that the water absorbed is Q equal to mc delta T. Before the start of this experiment, we know what is M, we know what is C of water, we know what is delta T of water. Now, we want to show that this heat has been absorbed. Means where did this heat come from? ये electrical energy से तो heat आया होगा ना, heater ने heat किया है. So if there is no loss of heat, which ideally is not, there will be loss of heat. This heat should be exactly equal to this heat. Heat bole to energy. Now, how do you find the energy this side? They will give you a power rating of the heater. So if you have confusion, power is always equal to energy upon time. That is joules. That is joules upon second, and then power's unit is watt. 1 watt is 1 joule over 1 second. They might give you the question in kilowatt and the time in minutes. This is the maximum confusion they can do for you. So you need to find out energy, which is power into time. First, convert the power from kilowatt to watt. So 20 kilowatt became 20 into 10 to the power 3. And 10 minutes became 10 into 60 seconds. अब ये करेक्ट है कि नहीं, उसको करने के लिए यहाँ पे करके देखा. हम लोग क्या मल्टीप्लाई कर रहे हैं अश्मिता? W के साथ S को मल्टीप्लाई कर रहे हैं. W into S. W का मतलब है joules per second into second. Second cut means we are correct, joules. And approximately you should get the same answer on both sides. Now we can design a problem where कुछ ना कुछ छुपा देगा. देखो, something we will hide. We'll hide, say, the mass of the water. Then how to find out the mass of the water? So how does our experiment, how does, so I'm just rubbing this. Say, suppose now, what are the players in this match now? The players in this match are the players in this type of a problem will be the power of the heater. Number 2 would be the time or duration. Agreed, bachcha log? Number 3 would be the mass of substance which you are trying to heat. It can be even milkmaid also, because festive season we must be making laddus. Ashmita won't make, she would make sweets only, okay? And she won't use milkmaid, she will use condensed milk, not paneer, cottage cheese. Number 4, mass of substance. Then we would need what is the specific heat capacity of that particular substance. And number 5, we will also have the rise in temperature. Obviously, if I am heating it, it has to be the rise in temperature. Okay? So power will be denoted by P, time will be in T. This is where your Cambridge is using theta. Do you get it? दो T आ जाएगा यहाँ पे, और कोई problem नहीं. Mass is M, this is C, and this is delta capital T. So our expression is always Q is equal to mc delta T. Q is a form of energy, so we can write it as E equal to mc delta T. E can be written as P into T, which is equal to mc delta T. Now this will be given, this will be given, this will be given, this. They may say what is the unknown. So don't be a dumbo. Please solve the problem and get the full marks. कोई एक छुपा देगा आपसे. Or they will give you initial temperature, not the final temperature. That they won't do. That you can't solve in that way. They'll give you rise in temperature, they will hide from you. बोलो बच्चा, समझ में आया कि नहीं?
Yes, sir.
Oh, great. Yes, sir. He is understood. Let's do some problem now. चलिए, इस बेसिस पर प्रॉब्लम करते हैं. Hey, when I first wrote that note, that I will hold the class on Thursday. How many of you cried at home? I will not do the class on Thursday. Asmita, number 1. Kirtan, you cried. Number 2. Dhruv, number 3. इन तीनों घरों से मुझे पहले आया, इट इज दिवाली सर, सो व्हाट, कौन सा बच्चा सुबह 6 बजे उठ के नहा वहा के आज दिवाली है. ऑल यू वुड बी लाइक स्लीपिंग लाइक क्रोकोडाइल्स ऑन बेड टिल 10 o'clock and 11:30 you are free. Even if you go out or somebody comes to your house, nobody will come before 11:30. You won't go out before 11:30. Even if you go now, you are not a kiddo that you'll go for buying crackers. Even if you go 9 बजे कोई क्रैकर का दुकान नहीं खुलता है. And the talk is such that Diwali means, sir, our children get up at 6 o'clock and they'll be having आरती थाली. भूतनी को बिस्तर में सोए रहोगे 10 बजे तक. Tell me, Sasra, am I lying? Touch the heart and say, hey, why didn't you come? Yes, फेस्ट के बाद वाला दिन तो गोली मार दिया, एक ना 2 दिन. ध्रुव, तू क्यों नहीं आया उस दिन एक्स्ट्रा क्लास? I want to know, what about? At least Asmita showed up her face at around 20 minutes delayed. Kirtan has got, wait, listen about Kirtan. He has a dental appointment which he himself is not aware the day before. Parents का दांत नहीं निकालेगा, उसी का तो दांत निकालेगा ना, and he's grown up. How can somebody be, hey Kirtan, get up, we have your dental checkup. मतलब Kirtan ऐसे दांत निकालने चला गया. Goli number 1. Okay, that was that. He has a dental checkup. If it was a dental checkup, then I will give you 2 slaps another. Then why didn't you open your mouth the day before that I have a dental checkup? Are you a mama's boy still now? In hostel you will go and your mama will tell you what, whether I've got a dental checkup or not. Tomorrow you have a dental checkup, you don't know by today. Then ध्रुव का केस देखो, क्लास वास शुरू हो गया, मैसेज तो आया कम से कम 20-25 मिनट बाद, वो भी सच्चा मैसेज. ध्रुव कुड नॉट ज्वाइन द क्लास ड्यू टू सम रीजन. वो रीजन तो मैं ही जानता हूं क्या रीजन है. सहस्रा अपनी दुनिया में, शी इज द बेस्ट. It was only me and Ahiri, you know, and then I thought there's no one joining. Then Nidhi suddenly joined up at just 4th, 5th minute, and then 3 of us were studying. At least that girl came up. बाकी सब तो ऐसे. चलो कोई बात नहीं, आपकी मर्जी. आइए क्वेश्चन करते हैं. So let's do this question. A tank holding 60 kg of water. Okay, so I'll write the data now. So our question is such that the mass M is equal to 60 kg. The tank is holding 60 kg of water, is heated by a 3 kW electric heater. Your geysers are usually, 3 kW. This is like a typical instant geyser. So we have a heater and the heater's power is equal to P, which is equal to 3 kilowatt. Okay, 3 kW heater, immersion heater. Specific heat capacity of water, that is C, is equal to 4200 joules per kg degree centigrade. Okay, estimate the time for the temperature rise. So our delta T has been given. Delta T is the rise in temperature is from 60 degree from 10 degrees. So I'm just directly calculating the rise in temperature is 50 degrees Celsius. So they have asked you estimate the time. कितना टाइम तक इसको, have you understood? First don't solve it, just first understand. It is typically your geyser problem. 3 kilowatt is an instant geyser. Right now in this flat also the geyser we have is 3 kilowatt. 3 kilowatt heating 60 kg of water. The temperature has gone up from 10 degree to 60 degree. Very much our bathroom problem. We generally bathe at 40 degree, 40, 50, they are heated up to 60. That means the rise in temperature has been 50 degree. How much time will have you seen when you switch on a geyser, it will be first red in color and then become green. Green means the thermostat has switched on. Now the temperature is constant at 50. Whenever the temperature falls, again the geyser will heat. Otherwise तो geyser heat करते रहेगा, अंडा boil हो जाएगा तुम्हारे इसमें. Geyser cut कर देता है thermostat. So the thermostat has cut now at 60 degree. That is your desired bathing temperature. Typical daily problem. तो इसका निकालने हैं. आइए, हमारा energy कितना होता है? Energy which is equal to nothing but the heat energy should be equal to mc delta T. And this energy is given by power into time, which should be equal to mc delta t. That means T should be equal to mc delta T over the power. M is given how much beta? 60 multiplied by 4200 into 50 divided by the power. And what is the power? The power is 3 kilowatt, which is 3 into 10 to the power 3. 10 to the power 3 cancels 2 zeros from here and 1 zero from here. And 3 into 20 is 60. 25 is 100. So 4200 seconds is the answer. Which means if I divide it by 60, 0, 0 gone, 6 sevens are 42 and 0. So 70 minutes. 70 minutes means 1 hour, 10 minutes. Who all used a calculator? Aya? Hey, learn. 1 minute. ये problem करना सीखो. रुको. Don't use the calculator. Hello. Up till this much is known to you, right? Yeah, don't do it. सीखो. Problem करना सीखो. 60 is the mass multiplied by 4200 specific heat. Delta T 50 divided by power is 3 kilowatt. 3 into 10 to the power 3. What is a 10 to the power 3? A 10 to the power 3 is a 1000. Yes or no? A 1000 takes 2 zeros from here and 1 zero from here. Understood? Then what? 3 cancels this as 23 is a 60. 20 into 5 gives me 100. 100 into 42 is 4200. So many seconds. Divided by 60. 0 0 cut. 6 7 42. 70 minutes. 70 minutes means 1 hour 10 minutes. बहुत ही फालतू गीजर है आपका. 1 घंटा लेता है. But the 60 kg water you are heating. Instant geyser are how much? 6 liter. 5 liters, 6 liters. This is how much? 60 kg. So you are having a very underrated heater to heat it. It's just like taking that Diwali ka diya and trying to cook Maggie out of it. It will take time. It's think physics like that. समझ में आया? चलें. एक और प्रॉब्लम. आइए. इसको आप लोग कीजिए. Okay. Let's take one more problem and finish these. Okay. Kirtan darling, how are you? Has the calculator given? Kirtan, do you have classes during Diwali? Sir, I need to leave now. You have class? How? Why are you having? You have a class today. You're not allowing your sir to celebrate Diwali also. Drum sir. Very bad. Okay, next. A piece of aluminum of mass 0.5 kg. So we have the M, which is 0.5 kg. Okay, is heated to 100 degree. Is heated to 100 degree. Okay, let's see the question. ये थोड़ा interesting है. Heated to 100 degrees Celsius. You have heated it to 100 degrees Celsius, and then placed in water. After that, you have placed it in. This is interesting. After that, you have placed it in water. This is water. And the mass of water is 4 kg, and this water is at 10 degrees Celsius. The water is at 10 degrees Celsius. Okay, so this is mass of aluminium, Al. Question: if the resulting temperature of the mixture is 30 degrees. Now please understand, students, this is the question that I was saying. You are taking aluminium which is heated to how much? 100 degree, and that means you are inserting that aluminium out here. So what got inserted? 100 degree. How much is the result? Then what was the temperature of water? 10 degree. After inserting aluminium, what we will observe? Aluminium's temperature should come down, water's temperature should go up. So we brought the aluminium and we put it out here. This aluminium was brought at 100 degrees Celsius, and then the rise, I'll not say rise, the temperature of water was observed to be 30 degrees, right? It's written that if the temperature of the resulting mixture, not water, it will be water plus aluminium. This mixture is now at a temperature of 30 degrees. समझ में आया ना? So 30 degrees. Then they are saying, what is the specific heat of aluminium? So you need to find out what is CAL. We don't know. and that of water is 4200. So CH2O, this is given to you 4200 joules per kg degree Celsius. Have you understood? ठीक है, ये प्रॉब्लम करते हैं, आ जाओ, ये तो एकदम इंटरेस्टिंग प्रॉब्लम. How many of you have understood the question? Forget about solving it. I have heated aluminium to 100 degree and I have put that aluminium in a water bath. This is called a water bath. The water was at 10 degree. After putting the aluminium, after some time, the temperature of water and aluminium together has reached how much? 30 degrees. Have you understood? So we have to find out what is the temperature. Right. So first you have to find out. Let's find out who lost heat. You tell me this first. Who lost heat? Aluminium lost heat. So let's see heat lost by aluminium. What should be the heat lost by aluminium? It should be mass of aluminium into specific heat of aluminium into delta T for aluminium. Do you have the mass of aluminium? Yes, sir. It is half. Sir, why didn't you use 0.5? It is better to calculate with fractions. Okay, half. What is CAL? Sir, I don't know what is CAL. ये तो निकालना है. And what is delta T? Can you tell me what is this value for aluminium? 100 minus 30. So we will write first as 100 minus 30. 100 degree का aluminium ठंडा होके 30 हो गया. So this is how much? 70. 70 means this should be equal to 35 CAL. That is the Q loss by aluminium. Yes or no? So let's see who gained heat. Water gained heat. So let's say heat gained by water. This should be again equal to M of water into C of water into delta T of water. So what is the M of water? Sir, 4 kg. C 4200 and delta T. Yes, tell me, Shastra, delta T for water. Yes, 20. So that should be 30 minus 10, which is 20. Very good. 4 into 4200 into 20, which is equal to how much? 80 into 4200. We'll keep it like this only. Okay, this much joule. Now this value and this value must be exactly equal. So if we equate them, we find 35 times of CAL should be equal to 80 into 4200 joules. So CAL half into 70, that is 35. Yeah. See, 80 into 4200 divided by 35. कितना होगा? 5 7 are 35. 5 1 are 5. 16. And then if we do it, 16 2s are 32, 2, 3 carry over, 16 4 64 plus 3 67 0 0 divided by 7, 7 9s are 63, 32, 7 4s are 28, 4 40, 7 5 35. Something garbad? 35, 5 7s are 35, 5 16. 16 2s are 32, 2, 3 carry over, 16 4 64 plus 3 67. 7 and 42. Yes, why am I doing that stupid way? Very good. Why am I doing that stupid way? 7 6 are 42 0 0. So 16 6 are 96 0 0. Yes or no? 16 6 are 96 0. 9600 joules per kg degree centigrade. We should not put this bar here. Joules per kg degree Celsius. So aluminium has more specific heat than water. Obviously it's a metal, वो ज़्यादा खाएगा. But the answer is वही तो मुझे गड़बड़ कर रहा है. It is 960 is their answer. Somewhere we have done mistake with a 0. Half CAL 70 35 CAL. What did we do here? 4 kg multiplied by 4220. So 4 into 20 is 80. 4200. 80 into 4200 divided by 35. So 5 7 the 35 16. Then 7 6 600. 16 6 9. क्या हो गया? कहाँ गड़बड़ हुआ है? some data. Oh, it is my mistake. Aluminium heated was 0.5. 0.5 is half. Correct. 0.5 into 70 is, oh, water, how much I have taken? 4. My mistake, bacha. The water was 0.4. 0.4 means this will be 88 only. Or you can say only this one. So it is 80 into 420. So this one is not there. So this one is not there. 960. Okay. Sorry. Question mein galti tha. Cannot be more than water. That's what I was saying. Water specific heat is very high. Aluminium will get heated very quickly. Done. So there are two practice problems now on the same thing that I will not do. Do this, and in the next class we will go very fast because the next class job we have actually done already in chemistry. Cooling curve, latent heat of fusion. I'll just revise those topics. We don't have numericals, but please finish these two. These two what? Practice problems. I have done this, and once we are done, this unit ends. And the next, you will 100% get a problem from here. The next unit is all about melting, boiling, and evaporation. Okay? Right, sir? So we'll break and catch up again on our next class.